All right, this video is to help you if you're stuck a little bit on your homework. Number 14. In number 14, they gave me just this chord piece and said it was 356, and this top piece, which was 60, and asked me for the diameter. So I went ahead and extended the circle. It's gone blurry. I extended the circle so that it would have the full diameter. I said this piece is X. And I'm going to use the chords theorem that's telling me part times part equals part times part of the other chord. When I solve through, I get about 528. That's the X. I have to add it back in with the 60 to get the diameter. So that one is about 588. Number 15 is following along that same idea. I knew that I had 12 for the chord, but it's coming in perpendicular, so I know it's being shared equally. So I gave each side 6. The 9 was given. I extended that missing piece of the cake and put the X. And part times part equals part times part. X is 4. The diameter is 9 plus the X, so the diameter is about 13. In number 19, I've got this fancy crazy circle with 2 different variables in it. I don't want to solve for 2 variables simultaneously, so I'm looking for what information I had. I looked first and I said, well, if I ignore these outside pieces, I would have chord for part times part equals part times part, and that would give me B times 8 equals 6 times A. But I said, oh, that's 2 variables, so I said, okay, let me look at these outside parts. I decided to ignore the B and 8 chord and look at the tangent of 10 and the secant 4A and 6. And I'm using that tangent squared equals secant times the external segment formula that we learned. So 10 squared equals 4 plus 8 plus 6 multiplied by 4. Solve through, and that's going to work out to giving me A is 15. Once I know that, I can use that chord part I was just talking about, where part times part of the first chord equals part times part of the second chord. So B times 8 equals A times 6, but I know A is 15. Plugging it in, my B is going to be about 11.3. And the final one I'm going to talk about a little bit is number 20. In number 20, the original is something along these lines. This is a Q. I know it looks weird. All right, so I need to figure out what part I can start with. I said, okay, let me just pull out. I know that looks like an 8 or something crazy in the camera. That's a Q. I said, let me look at this secant. No, I didn't need this external segment outside of it because I'm working off of this shared external point. So I'm going to pull out the Q and the 16 and then the 15 as the tangent so that I can use tangent squared equals the secant times its external segment. The tangent's 15, the secant is Q plus 16, the external segment's Q. So 225 equals Q squared plus 16Q, got it all together. And 225 I knew would factor, so I played with it a little bit. 25 times 9 has a difference of 16. I just figured out which one's positive, which one's negative, and I know it's got to be Q equals 9 because I can't have a negative distance on a circle. Now I'm looking where the other piece is, and I'm going to say, ooh, I can use the 2 secants. Again, I don't need to extend outside the other part of the circle, and I'm going to use secant times the external segment equals secant times the external segment. So in the first one, 16 plus 2, or 18 is the secant, external segment's 2. 18.5 plus R times R for the other one gives me something that becomes R squared plus 18.5R minus 36. I'm not going to be able to factor that, so I'm going to say that A equals 1, B equals 18.5, C equals negative 36, and then I'm going to use my quadratic formula, the negative B plus or minus B, the square root of B squared minus 4AC over 2A. I don't need the negative answer there, so I don't need to do the negative B, take away the value in the square root, because it won't be negative. I just need to do the one with the plus. And when I work through that, I got about 1.77, which gives me an R of about 1.8. Hope that is helpful. Watch it as needed. Work through it along with me and see if you can make sense of it.